Okay, so what we're going to look at now is how to solve and draw the cubics. So, I don't think it's a problem to see where it crosses the y-axis. How do you find that? What do you do? Yeah, just, sorry, where did my x go here? X. You make x equal to 0, and then what will y equal here? 24. So, I mean, that point is easy to find. That's 0, 24. In fact, it's always this 24 bit at the end. So the real problem, I suppose, is trying to find where it crosses the x-axis. So how do we find where it crosses the x-axis? Well, that's when you make y equal to 0. Yeah? So you want to solve 9x cubed plus 10x squared minus 43x plus 24 equal 0. You make y equal to 0. Okay? And let me just show you a cubic here for the moment. We'll go back to this in a second. So suppose I have x minus 3 and then 2x plus 1 and then 2x minus 9. Simplify, expand. Okay, you already know what the factors are because you just saw me input them at the top. So what would be one root for this? What would be one example for this? 3, yeah. 3 would be one root. If I told you x minus 3 was a factor, then what you could do is a long division. So you could do this long division, and what you should end up with is a quadratic. And the quadratic here, what do you think the factors of this quadratic will be? 2x plus 1 and 2x minus 9. So watch this. Which they are. So anyways, my point is, if you want to solve this, I need to tell you one of the factors. So if I told you x equals 3 is a root, then you know what the factor is. So if I said x equals 3 is a root, then what's the factor? X minus 3. But if I don't tell you this, what should you do? What could we do to try to continue? But to find. How do we find? This is the key. Maybe, kind of. I know the sure, I can use the program to do it. So what you need to do is you need to start trying different values of x until you find a root. So for example, yes. So for example, you could try x is 0. Now I know x is 0 is not going to work because what am I left with? 27. I could try x is 1. Will that work? No. I could try x is 2. Will that work? No. I could try x is 3. Would that work? 0. So x equals 3 is a root. That means x minus 3 is a factor. Now in the exam, the good news for you is the limit is minus 3 to plus 3. So you will only ever need to check these numbers. Yeah. So we need to start guessing. Now, you can be smart sometimes with these. Let me give you an example of what I mean by smart. So for example, imagine that this, for example, was a plus. If it was like this, I know that x must be negative. Why? Because of plus, the only way to make it zeros is some of them are negative. So because they're mostly plus and only one of them is negative, I feel like maybe the answer will be negative. So I'll first start at the negatives and then the positives. Okay. Secondly, if we go back to this one here, let me just delete these for a second. Can you see this 27 here? Yeah, this 27, if you look at the numbers at the back, 3, 1 and 9, they all divide into 27. Of course they do, because the 27 is 9 multiplied by 1 multiplied by 3. Yeah? So what you could try is you could try numbers that divide into 27 and numbers that divide into 27 divided by 4 as well. But if you just look at numbers that divide into 27. So if I look here, what numbers divide into 24? 1, 2, okay, 3, and there's many more, but I don't need to try that. Yeah. Okay. So before I start, I think using 3, I'll do that last because this I think will get too big. So I really want to try -1 or -2 first. So which feels lucky to you, -1 or -2? Everybody feels lucky about -2. Okay, let's try x equals -2 first. 9 minus 2 cubed plus 10 times -2 squared minus 43 times -2 plus 24. No, it's way off. Yeah, we'll go back to -1, will we? Oh, it was -3. Oh, right, okay. -3. Are you sure?
Yeah.
You checked 3, okay. So if you try, so this is no, so now we go on to -3, and that's a yes. Success. So you know that x minus 3 is a root, so then what is the factor? X plus 3 is the factor. So actually, hang on, since you know that's a root, we might as well mark it in here. -3, okay. Now, how do I find the other two? Well, we just do our long division. Let's do this one here now. What? So sad. That's life. 9x squared, 9x cubed plus 27x squared minus 17x squared minus 43x plus 24 minus 17x x squared minus 49, no, 51 x 57, 8x minus 24. Ugh, ugly. Plus, right, plus 8. And then when you multiply, you get 8x plus 24, so you're finished. So we just need to find the factors here. Cheating time. 9 minus 17 and 8. X minus 1 and 9x minus 8. Now you don't have to find the factors, you can just use the quadratic formula. That's all. Okay, so what is the next root? 1 and, what's that, 8/9? So that would be around about here. 8/9. Okay, does anybody know what shape the cubic makes? Does it, for example, does it rise at the beginning or fall? Yeah, well, if it's a positive, it will rise at the start, and if it's a negative, it will fall. So it'll have to pass up through this point, down through this point, down here, and then it must turn around to go back up this point and out like that. Okay. Ah, work of art. Let me show you what a nice one looks like. 9x cubed plus 10x squared minus 43x plus 24. Okay, so let me just zoom out a bit. Now you see, it looks like it touches only once, but it actually is twice, because if I was to zoom in, see, it just dips under. Okay. It actually does go twice here. Yeah, same idea. Yeah. Okay. You do get this in the exam, and in the exam, they want to see the 4 points on the graph. They want to see root, 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 and intercept. for full marks.
What about the maximum and minimum?
No, they won't expect that for semester 1. Semester 2 will be different though. Yeah, okay, so can you write this one down and we'll do another example. Okay, you got that? No. Yes? Yeah. Alright, let's have a look at the next example. So you want to solve and sketch this one. Okay, so firstly, if I make x0, what's y? Come on. No, don't all say it together. If x is 0, what's y? 1. There you go. Okay, now this one actually is a little bit easier because I definitely know x is negative if I want to start guessing. So, wait. I know x is negative. Okay? And because of the 1 at the back, I should really start with just 1, because the only number that divides into 1 is 1. So I really hope minus 1 does the job, because otherwise I don't see what my other options are. Minus 81 plus 99 minus 19 plus 1, success. Yeah, it's all positive, so it must be negative, the x. And it must be a number that divides into 1, which is only 1. So if I start at x equals minus 1, I've gotten the answer already. So x minus 1 works, so therefore x plus 1 is my second point here is minus 1, 0. So that is a factor, 81x cubed plus 99. Yeah. Okay, what's first? Let's see how quick we can do this. 81x squared, 81x cubed plus 81x squared. I subtract, that's an 18x squared, right? Plus 18x plus 19x, that's 18x, and the 1 comes down. 18x squared plus 18x. I subtract and I'm left with x plus 1, so what's the last one here? 1. And when you factorize this, or use the quadratic formula, whatever you get, both will be the same, I think. So you get 9x plus 1, and the other factor is actually 9x plus 1 as well. So you really only have one root here. Minus 1 over 9 and 0. Okay, so let's have a look at what this graph looks like. So we have here 0, 1, which will be here. and then minus 1, 0, which will be here, and then minus 1 over 9, 0, which is there. So I don't have 3 points, so it doesn't go, it can't go up, down, up again, because there's only 2 points on the x-axis. So what happens here is, it rises, and then it drops, but as soon as it hits this point, it goes back up again. That's ugly, I know. Let me just scooch this a bit to the right. Okay, let's try that again. So it goes up here, down, up. So it touches the x-axis twice. Yeah, it's a minus 1 over 9.
It's like score 3 minus 26. It's the graph.
That's which one? The last one?
Yeah.
It looks like it, but this does actually only touch it once, whereas my last one, it touched it twice. Yeah. Let's draw the nice cubic. Okay. Yeah, the nice one. The one everyone wants to be friends with. 81x cubed
99.
plus 99x squared plus 19x plus 1. Yeah, now let me just... Oops, too much. Yeah. So at minus 1 and at minus 1 over 9. I don't think I marked this point in, did I? No, I did. Yeah, there's a scale issue here. Well, that's because I went up to 20 here, whereas in this graph I only went up to 2. So if I only went up to 2... No, wrong way. Yeah, if I only went up to 2, it looks more in the middle. Anyways, that's what a nice one looks like. Okay? Got that? Hey, focus. Come on. You got that one? Yeah, so we can write this down. We'll do 2 more examples then. So this one, please. You got this one?
Yeah.
Yep. All right. Okay, next one. Y equals 16x cubed plus 56x squared plus 49x. All right, this one's great because I can see straight away what the x needs to be. Yeah. So if x, well, in fact, what I could do is factorize it automatically. I could take the x out and have here 16x squared plus 56x plus 49. Yeah. I took the x out in front. So if I let y equal to 0, I get x 16x squared plus 56x plus 49 equals 0. This is now letting y equals 0.
Might be 0.
X could be 0, yeah. So the first point you have is x is 0 and y is 0. So now I need to factorize this. But if we have a quick look at the discriminant, I don't think it has factors. 56 squared minus 4 times 16 times 49. Oh no, it does. The discriminant is 0, which means it's the same one twice. So here, if I continue with my factor in, 4x plus 7. 4x plus 7 equals 0. So this is great. You can see what the factors are, the roots are. X equals 0 or minus 7 over 4. Twice, yeah.
So it was like
Yes.
one on this side and one on that side, or?
I'll show you now. We'll draw it. Can I slow down? Yeah. Okay, so there's x, there's y. So the first root is at 0, And the second root is at minus 7 over 4. So if I split it into ones like this, minus 7 over 4 would be about here. Okay. Right. Now, we just have to be careful with this one. Okay, so we could draw it like, see, we only have 2 points. So you have to be very careful about this. We have to think, how many possible ways do I have to draw it? So we know that we must rise at the start.
This one is like the minimum.
This
Right.
one here?
Yeah.
Yes, it could be up here, and then down, and then back up. Yeah, that's one way. But is there another way? No, I think this is the only way to draw it. I think. Because it has to go up at the start,
Yeah.
it has to pass through this point, so that means it has to go down here. No, there is another way to draw it, yeah.
No, like, but
No, I think this is it. Yeah, go on.
and the but like
You guide me. Up, 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 up.
down.
Excellent. Yes. So, very good. There is another way to draw it. You could go up, straight down, and then up again. Good man. So, in fact, you have 2 possible graphs. This is what you're thinking, was it?
Yeah.
Yes, good job. So, you have 2 possible graphs here. So, how can we decide which one to draw? I know you can. No, we won't do that.
Let's suppose the x equals minus 1.
Yeah. Put it. If you put x equals minus 1,
Yeah.
if you get a positive y value, you must have the blue graph. And if you get a negative y value, you must have the red graph. So if I put minus 1 in, I'll get minus 16 plus 56 minus 49. That's negative, isn't it? So the correct one is the red pill. Okay. Yeah. And I'll show you a nice one. 16x cubed plus 56x squared plus 49x. Okay. Let's draw that. There you go. So that's what it looks like then. Okay. Okay, can I go on to the next one? Come on, please get silent. Yeah. Next one? Yep. Okay, so this one here now, you want to know when is this less than 0? Yeah. So, what I'm going to do first to make the problem a little bit easier is multiply everything by minus 1. So you have 5x cubed plus 24x squared plus 34x plus 21 greater than 0. You might remember this, that when you multiply by minus 1 it turns it around. Okay, so what we want to do is we want to draw this now. Now because I've done 3 examples already, I won't repeat it again. I'll just go straight to the graph because you know how to do it. We've done it a few times. So if I graph this straight away, what was the cubic? Y equals 5x cubed plus 24x squared 34x plus 21. Now look, we can almost guess what the first root is. Should it be a positive or negative? Negative. Numbers that divide into 21, what are they? 1, and 3. So it's either going to be x equals minus 1 or x equals minus 3. Which do you think is more likely? I kind of feel good about minus 1. Shall we see? Actually, I meant to say I feel good about minus 3. So if x minus 3 is a root, then the factor is x plus 3. You do the long division, you get the quadratic, and you get 2 more. Okay, so let's pretend we did that. And we draw the graph. So the graph looks like this. Okay, and in fact this one had no roots except for the one we found at the start of minus 3. So that means the quadratic you got after the long division had no roots. Okay. Now remember, we are looking for when this is greater than 0, not equal 0. Here, this is when y equals 0, minus 3. This part of the graph to the right, this is when the y is positive. This is positive y. And this graph here to the left, that's when the y is negative. So if you want the y to be positive, it means your x must be more than minus 3. Because if your x is less than minus 3, it's negative. So with these questions, you use the graph, and you get an answer of x must be greater than minus 3. Okay. So this is how this is an example of a question where you have to use your graph. Now, when you do use the graph, you can still be accurate because you know exactly what this number is here, because this is the number you got at the beginning. So there's no guessing; it's exact. Okay. Right.
Say like x greater or equal to -2?
No, it must be greater because. Can anyone tell me why?
What?
He said, could he write it like this?
No, like -2. With minus. Yeah, the same as this, but
Yeah.
-2.
Oh, I see what you mean. X greater than or equal to minus 2.
Yeah.
Now, if you did do that, you would miss out the numbers in between.
Okay.
Yeah. So we'll keep it like, like this. So, I mean, you don't have to write this down. I'm just trying to show you what you can do with the graph after you find the graph as well.
Can we see
Okay.
the graph again?
Yes, there it is, right there. Okay, so in number 1, OPQ. And then in number 2, B. Yeah.
B.
Now listen, I've only given you 4 graphs to draw, so I want nice graphs, okay? Yes? Yeah. I don't want any, no x-axis, no y-axis. I want nice graphs, because in the exam, you will likely get a question like this. In the exam, there's always one graph question, okay? Alright, we'll finish there.